Okay, this is number 3 from 14.3. I'm going to show you the first part, finding dz dx, partial z with respect to x, using implicit differentiation. Okay, well, on the left side here, it's a sine function, so the derivative of the sine is cosine. So we get cosine of x, y, z, and then by chain rule you have to take the derivative of x times y times z. So, okay, if I consider x the first function and y times z the second function, take the derivative of the first times the second, gives me y times z, plus the first times the derivative of the second, which would be x times y partial of z with respect to x. So that's from the chain rule. And then on the right side we get 1, the derivative of 2y with respect to x goes to 0, plus 3 times 1 dz dx, partial of z with respect to x. And then it's just a matter of multiplying things out. If I distribute the cosine here, I'll have, okay, y times z cosine x, y, z plus x times y cosine, well, you know what, I think I'll write it as x times y dz dx partial of z with respect to x times the cosine of x, y, z. Equals 1 plus 3 partial z with respect to x. Okay, so we need to get everything with dz dx on the same side of the equation. So I'm going to write that. I'm going to get everything with dz dx on the left hand side. So x times y dz dx cosine x, y, z I'm going to leave on the left side. I'll subtract out the 3 partial z with respect to x to get it to the other side, and then to get everything with dz dx on the left side, and then on the right side we'll be left with 1 minus y times z cosine x, y, z. Let me make some room here. Okay. Now on the left side all I have to do is factor out dz dx, partial of z with respect to x, you should probably say. What's left inside is x, y cosine x, y, z minus 3. And then the right side hasn't changed. Okay, and then the last step is just to divide by the quantity in brackets. Partial of z with respect to x equals 1 minus y times z cosine x, y, z divided by x, y cosine x, y, z minus 3.